Okay, we're going to do a little bit more with asymptotes. In the last video we talked about vertical and horizontal asymptotes. There is another type, I mentioned it in the other video, in which you have a rational function and the degree of the numerator is 1 more than the degree of the denominator. So right here, 1 greater than the degree of the denominator, we have what we call a slant asymptote, or sometimes it's called an oblique asymptote. And that's exactly what I have here with this particular example. It says determine the asymptotes of. Well, I have a vertical asymptote because, as you can see, -1 is going to make my denominator 0, but it won't make my numerator 0. So I have a vertical asymptote. Here, let me write this vertical asymptote of x equals -1. But I don't have a horizontal asymptote because the degree of the numerator is greater than the degree of the denominator. But since it's only 1 greater, what I know here is that I'm going to have what we call a slant asymptote. Now, how do you find the slant asymptote? You divide. I'm going to divide the numerator by the denominator. So I'm going to put, let's see here. This would be, there's no x term, so this would be 2, 0, -9, and a -1. So I bring the 2 down, that's -2, that's a -2, that's a +2, that's a -7, that's my remainder. So what this tells me is that this is 2x minus 2, and that's the remainder. Well, what happens is that remainder is over x plus 1. So as x gets bigger and bigger and bigger and bigger, and goes to positive infinity, or as x gets smaller and smaller and smaller and smaller, and it goes to negative infinity, my denominator is getting huge, my fraction is going to 0. What happens is this expression goes to this expression. Graphically, what that means is the graph, as x gets really big, goes to infinity or negative infinity, approaches the graph of y equals the quotient here, 2x minus 2. And that line there is what we refer to as an oblique asymptote or a slant asymptote of this graph. Now I'm going to do an example, actually I'm going to do about 3 or 4 examples of some graphs, and one of them will involve a slant asymptote, so you can kind of make note of that. Now, how do we graph a rational function? Well, we try to graph a rational function if we can based off of the parent graph, the reciprocal function. And then we do translations and stretching and shrinking and reflections as necessary. Now remember, the original function here, f of x equals 1 over x, has a horizontal asymptote that is the x-axis, y equals 0, and a vertical asymptote that is the y-axis, which is x equals 0. Now, if you look at this guy right here, and then look at my first example, you can see there's a 3 subtracted from the x. That's a horizontal translation. You're subtracting 3, so that's going to move it 3 units to the right. The -2 on the end, that's a vertical translation. Because it's a -2, that's going to drop it 2 units. So if we start, and I'm going to go ahead and put the graph of the original in here if I can. If we start with the parent graph, well, that's supposed to kind of go downward. There we go. And okay, kind of rough there. If we start with the parent graph, what happens is the parent graph is shifted 3 to the right and 2 down. So what I'm going to do in a different color here, so you can see it a little bit easier, is I'm going to take some of these points that I have and I'm going to shift them 3 to the right and 2 down. For example, I have the point 1, 1. 1, 1 is clearly on that graph. Well, 3 to the right puts it at 4, and 1 down puts it right smack dab here. What happens to the asymptotes is that they get shifted 3 to the right, so the y-axis, or x equals 0, gets shifted 3 to the right. So now my horizontal asymptote is here, and my vertical asymptote, oh, I'm sorry, I think I already did 1 down, it's actually going to be 2 down. My horizontal asymptote is the y, or the x-axis, y equals 0, but it's been shifted 2 down. So what happens here is, 1, 2, it's going to look like this. Okay, now picture this as if it was like the new x and y axis, and everything else remains the same. That is not a very well graphed point. Let's try that again. There we go. And so my graph, this branch of this graph, is going to go like this, and it's going to go like this, and then this branch is going to be coming down this way and then going this way. Now, that is not a very well drawn graph because I need to plot some points. My suggestion is make sure that you plot a few points on each piece, because if you have a vertical asymptote or more than one vertical asymptote, you're going to have pieces of the graph here, and so I would make a t-chart, plot a few points. I'm definitely making a t-chart on this one because this one looks a little bit different in format than that. Here you can see the transformations done to the parent graph. Here you'd have to rewrite this to be able to see those transformations, but I'm going to show you what to do here all the same. And I'm going to start by graphing this one by finding any kind of asymptotes. So I have here a vertical asymptote, the denominator is 0 when x is 4, of x equals 4. You just set the denominator equal to 0 and solve. 4 does not make the numerator 0, so it's not a hole in the graph, it's just a vertical asymptote. And because the degrees are the same, degree 1 on the top and the bottom, I have a horizontal asymptote of, well, let's see, what's the lead coefficients? They're both 1, so it would be y equals 1. So the first thing I'm going to graph here, and apparently I didn't make this graph quite right. I've got all the emphasis on this end. Doggone it. Well, we'll see what we can do here. Draw in my horizontal and vertical axes or asymptotes there, and I have those done in red. Now, to find some points, I am very much going to make a t-chart. And I'm going to plug in as many points as I think are necessary. Now, most of my fun stuff is happening here at 4. So I would probably plug in 0, 1, 2, 3. I can't plug 4 in, but I might even plug 3.5 in and 4.5 in, because I want to see what happens when I get close, if it drops off or if it goes upward and such. And then probably 5, 6, and 7, but I don't think my scale goes out that far. 5, 6, and yeah, I guess it does. 7, there we go. So if I plug some of these values in, if I plug 0 in, I get -1 over -4, that's 1/4. If I plug 1 in, I get 0, so there we go, there's the x-intercept. If I plug 2 in, I get 1 over -2, that's -1/2. If I plug 3 in, I get 2 over -1, so that's -2. If I plug 3.5 in, here's where it gets a little dicey. 3.5 minus 1 is 2.5. And 3.5 minus 4 is -1/2. So this is 5/2 times -2 over 1, so this is going to be -5. If I plug 4.5 in, 4.5 minus 1 is 3.5. And 4.5 minus 4 is 1/2. So this is 7/2 times 2 over 1, or 7. It gives you an idea how high up or how low down and what angle kind of the severity of the drop, the increasing or decreasing by having these values. By plugging 5 in, I get 4 over 1, which is 4. Plug 6 in, I get 5 over 2. Plug 7 in, I get 6 over 3, which is 2. And that should give me what appears to be 2 branches. Because of the way I have a horizontal and a vertical asymptote, I suspect I'm going to have graph here and here, or graph here and here, and I'll plot some points to determine that. 0, 1/4, there's my y-intercept. 0, 1/4 would be about here. 1, 0 is here. 2, -1/2 is here. 3, -2 is here. And 3.5, -5, 2, 3, 4, 5 is down here. Do you see the curve here, the branch of my graph? So plug in more points to get a better idea of your sketch. See if I can make that look a little more effective there. And then on the right side there, I have some points. I have 4.5, 7. 4.5, 1, 2, 3, 4, 5, 6, 7. I've got that. Then I have 5, 4. 1, 2, 3, 4, 5, 4. I have 6 5/2 or 2.5, 6, 2.5, and I have 7, 2, and you can see the curve here. Now, when I set up my axes, I kind of had in my head what the graph was going to look like, but apparently I shifted it in the wrong direction, so it would probably be a little bit more emphasis on this part of the graph to get a good look at what's going on. So you can see the curve a little bit better. Let's put an arrow up here as well. Alright, and hopefully that gives you a bit of an indication. Definitely want to make a table, definitely want to use graph paper when you're working these problems out.